Connective tissue is a complicated tissue for most students because there's such a wide variety of tissues in this category. It is the most abundant tissue and it's widely distributed throughout the whole body. There are four main categories to connective tissue. We have connective tissue proper, which is going to cover 6 different tissues, and then we have cartilage, bone, and blood. And so what's going to tie all these things together is their origin, a common origin, because we have such diversity here. Now, the functions of connective tissue would be binding and support. That's what gives it its wide distribution throughout the body. Also protection, insulation, and transportation. The protection is going to be, there's a wide variety of protective issues. For instance, bone protects us, like protects our brain, protects our lungs, protects our heart, whereas the blood has protective issues like protects us from bleeding out. Platelets protect us. Our white blood cells protect us. Fat protects our kidneys, for instance. And fat is going to be one of the connective tissue. It's going to fall into connective tissue proper. Insulation. Our fat insulates us. Transportation comes with, you can think of bone as transporting us if muscle attaches to bone, but muscle is not a connective tissue. But transportation really comes in the form of blood, because blood transports oxygen throughout our body. Blood transports gases like oxygen, carbon dioxide. Also, blood transports hormones throughout the body and nutrients throughout the body. Okay, so here's what's going to tie connective tissue all together. These four things: the common origin, extracellular matrix, what's it made of, etc. Its main tie is this common origin, mesenchyme. All of the connective tissues come from a common origin, this embryonic tissue called mesenchyme, and actually mesenchyme is going to be derived from mesoderm, which we're going to cover in another lecture. Mesenchyme comes from mesoderm, if you want to write that down, but mesenchyme is an embryonic tissue, and mesenchymal cells are going to stay in all the connective tissues forever throughout your adulthood. These embryonic cells called mesenchymal cells, and that's going to help us if we ever have to, if our connective tissues have to repair themselves throughout life. Okay, our extracellular matrix. Extracellular matrix is going to be anything outside the cells. It's going to be where our cells reside. Unlike epithelial tissue is going to have a high degree of cellularity. That means there are going to be lots of cells in our epithelial tissue. Connective tissue, they don't have a lot of cells in there sometimes. Sometimes it's just a lot of matrix and just a cell scattered here and there. Sometimes there are lots of cells in our connective tissue, but a lot of times it's just more matrix than cells. Now, there are three main elements to our connective tissues. What I want you to focus on, especially in lab, is that you're going to have cells in connective tissue, you're going to have ground substance, and you're going to have fibers. Look for the fibers. What kind of fibers do you see in the microscope? What does the background substance look like? The ground substance look like? Is it solid? Is it liquid? Like for blood. The ground substance for blood is liquid. Do you see the fibers in blood? No, you don't. The fibers in blood are soluble. What kind of cells do you see? So this is going to be important. Now, there are going to be different degrees of vascularity in our connective tissues. Like, for instance, cartilage is avascular. Remember, if you put an A before a word, it means without. So cartilage has no blood vessels, whereas bone has a high degree of vascularity. Bone has lots of blood vessels in it. That's why bone repairs itself very easily. So this is an important concept to me for you to understand connective tissue. It's the fact that for each connective tissue that you look at, think to yourself, what kind of cells do I find in this connective tissue? What is the ground substance like? And what types of fibers are there? We're going to run into 3 different types of fibers. We're going to run into elastic fibers, collagen fibers, and reticular fibers. Do I have more elastic fibers in this type of connective tissue? Do I have more collagen fibers? Do I have more reticular fibers? Or for the ground substance, like I said before, is the ground substance totally solid? Is it more molasses-like? Or is it liquid, as in blood? And the cells, do I have more of one type of cell? Do I have just one type of cell? Do I have a wide variety of cells? So you've got to ask yourself these things for all the different types of connective tissue that you're looking at underneath the microscope. For our connective tissue components, we're going to look at the cells, the fibers, the ground substance, just like in this last slide when I was telling you that it's important. Uh-oh, where are we? These three main elements here is the cells, the ground substance, and the fibers. Here are our components: cells, fibers, and ground substance. Each cell does have each connective tissue does have a dominating cell type. And that cell, usually when a connective tissue starts out, usually the cell is undifferentiated. That means it's not specialized. And if it's not specialized, if it's undifferentiated when it starts out, it's called a blast cell. Blast, if you see the suffix blast, here we have blast, 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 blast. That means it's not specialized yet. It's an immature cell. Blast cells actually make the connective tissue. If you see the suffix site, here we see site, that's a mature cell. Sites, if you see the suffix site, that means it's a mature cell. Site cells maintain the connective tissue. So here we have a fibroblast and here we have a fibrocyte. So this is an immature cell that's undifferentiated. It's not mature yet. This type of cell would have made the connective tissue, and then once it matures into a fibrocyte, then it maintains the connective tissue. Here we have a chondroblast. This type of cell would have made the connective tissue. This type of cell maintains the connective tissue. And notice we have different prefixes here: fibro, chondro, osteo. These prefixes tell you where this type of cell lives. Fibro indicates it's in a connective tissue proper. Chondro indicates it's in a cartilage. Osteo indicates it's in a bone. I highly recommend that you guys take a medical terminology class, because this is what medical terminology is all about: prefixes and suffixes. So we're going back here. So each type of connective tissue is going to have a dominating cell type in it. For fibers, we have three types of fibers in connective tissue. We have collagen fibers. Collagen fibers are the strongest type of fiber. That's why I put it in bold. Collagen fibers are strong. They have tensile strength. Tensile means, well, strong. If you pull on them, they're not going to break. Elastin fibers. Elastin fibers are for elasticity. They have lots of recoil. We usually call collagen fibers, by the way, white fibers, because they look white and glistening when you look at them when they're fresh underneath a microscope, white and glistening. Now, elastin fibers, we call those yellow fibers. That's why it's in yellow, and they have a lot of recoil. Reticular fibers are also collagen fibers, but they're much smaller collagen fibers, and reticular fibers form a network. Reticular means network, and so we find them in areas where we need a mesh network for cells to reside in. And so cells will, you can think of them like forming a hammock, like if you like to lay in hammocks, so cells would lay in this little mesh network of reticulum. So we have our cells, then we have our fibers. Those are our first two connective tissue components, and now we're going to have ground substance. Now the ground substance is the background where the cells and the fibers will be, like a background, like the air. Except for this is not going to be air, it's going to be wetness, and this wetness is going to be composed mostly of interstitial fluid, and interstitial fluid is derived from the blood. It's a blood filtrate. It was filtered out of the blood, so it's mostly water and other solutes that came from the blood. So there's all kinds of things in there, ions and hormones and everything else. But also there are these sticky things called cell adhesion proteins. So those cell adhesion proteins would help these cells stick to these fibers. That's what cell adhesion proteins are. And then there's these sticky proteins called proteoglycans, which are just made of proteins plus these things called glycosaminoglycans. And glycosaminoglycans are large, negatively charged polysaccharides. They're large, negatively charged polysaccharides. So The important polysaccharides to know are chondroitin sulfate, keratin sulfate, and hyaluronic acid. Hyaluronic acid mostly comes up in our cartilages, and the more of these that you have, we can call our glycosaminoglycans GAGs. The more GAGs that you have, the more water that you can trap, and so the more viscous or solid that you become. The more glycosaminoglycans you have, the more viscous you become. And so here is a glycosaminoglycan. Well, all of these are little glycosaminoglycans right here. You can trap water in these little areas here, and you become more molasses-like, more solid. So our cartilages have lots of glycosaminoglycans, lots of hyaluronic acid. These areolar connective tissue has a moderate amount of glycosaminoglycans, and so the more GAGs that are secreted by these fibroblasts, the more water we'll trap, the more viscous we'll become, and the more swollen we can become. More water that we can trap, but the cartilage has lots of glycosaminoglycans. Lots of glycosaminoglycans. Okay. Here what we're seeing is this is a nice little thing for you all to understand. It has our common embryonic origin, which is mesenchyme to all the connective tissues. Because we have such diversity, we have the connective tissue proper category, where we're going to see all of these connective tissues. We have cartilage, bone, and blood, our connective tissues. They're all coming from this common origin, mesenchyme. So the mesenchymal cells, these little baby cells, differentiated. That means they turned into fibroblast, they turned into chondroblast, they turned into osteoblast, and they turned into these cells called hematopoietic stem cells. And these cells made all of these types of tissues. These cells made these tissues, these cells made these tissues, and so forth. And so this gave rise to all of these different types of tissues. So let's go into our fibroblast. So fibroblasts, when they mature, they become fibrocytes, and those fibrocytes maintain these types of tissues. So let's talk about connective tissue proper. And the connective tissue proper category, by the way, here's a fibroblast clinging to a collagen fiber. In the connective tissue proper category, we have two main classification or subclasses. We have loose connective tissue, and we have dense connective tissue. And we separate these two categories on the basis of how our fibers are arranged. In loose connective tissue, we have loosely arranged fibers. See, we have loosely arranged fibers. In dense connective tissue category, we have densely arranged fibers. We have a lot of dense fibers. So we have three categories under loose connective tissue. We have areolar connective tissue, adipose connective tissue, and reticular connective tissue. Here we'll find few fibers. In dense connective tissue, we have regular connective tissue, irregular connective tissue, and elastic connective tissue. In these categories, in areolar connective tissue, we have lots of all three fiber types. In adipose connective tissue, you find few fibers at all. And in reticular connective tissue, you have the reticular fibers only. Down here in these dense connective tissues, you find collagen fibers only, basically. I mean, I'm not saying you can't find any of the other fibers, but this is just a generality. Collagen fibers only, and down here we have elastic fibers only. So these are some general guidelines for you to understand. Okay, we'll see these on the slides here in a minute. In the cartilage category, we have chondroblast. These chondroblasts make the cartilage. When they make the cartilage, they become trapped in little caves called lacunae, and as soon as they become trapped, they differentiate into these cells called chondrocytes. And these are the three different types of cartilages: hyaline cartilage, fiber cartilage, and elastic cartilage. Hyaline cartilage has collagen fibers in it, but they're so fine you can't see. Fibrocartilage has lots of collagen fibers that you can see, and elastic cartilage has an abundance of elastic fibers. So there's the difference between the three. Collagen fibers you can't see, collagen fibers you can see, and elastic fibers. When we get to bone, the osteoblasts make the bone, but when they get trapped in lacunae, they become osteocytes. And we have the bone. There really is not two different types of bone. When you look underneath a microscope, there's little bone that's compact, and then there's spongy bone. It's not like spongy, like as in when you touch it, it feels like a sponge. It just looks like a sponge when you look at it. It's called cancellous bone. And then we have our last connective tissue category. It's called blood. If you look underneath a microscope, you're going to see red blood cells, white blood cells, and in this picture we don't see any little tiny platelets. They'd be little small specks in this picture. But blood is all derived inside of bone marrow, from an originator cell called hematopoietic stem cell. And the hematopoietic stem cell gives rise to the red blood cells, the little platelets, if we'd have one in here, and also to white blood cells. Now this tissue, blood, has a liquid background, which is plasma, and then it has these cells. And something I did not mention in class is that the fibers, where are the fibers? The fibers are actually soluble. That's one thing you don't see, soluble fibers. Soluble fibers. The fibers are actually dissolved in the plasma itself. Unlike all these other things where we see collagen fibers and elastic fibers and reticular fibers, the blood fibers are soluble. So here are our connective tissue types: connective tissue proper, collagen, bone, and blood. You definitely have to know everything on here. You have to know loose connective tissue, dense connective tissue. You have to know the three types of each, and you have to know where you find all of these different types of connective tissue. So with irregular connective tissue, it's everywhere. It's everywhere. It's all over the place. And the reason it's all over the place is because it's under all epithelia in the body. Everywhere you have epithelial tissue, you have at least a scanty layer of irregular connective tissue underneath it. So if you can see epithelial tissue, you're going to find at least the smallest amount underneath it, even under skin. Skin, which is keratinized, stratified, squamous epithelium. Underneath your skin, you're going to have a massive amount of dense, irregular connective tissue, because that is your dermis. But just before you get to the dermis, you're going to have a small amount of irregular connective tissue. So even under your skin, you're going to have irregular connective tissue. It's just everywhere. The irregular connective tissue holds a lot of water, holds a massive amount of water in your body. So it's everywhere. It's a very important tissue in your body. It wraps every blood vessel. Everywhere you have simple squamous epithelium in the body, you have irregular connective tissue. It's just great support. I can't stress how important this tissue is to your body. For adipose connective tissue, we find it right directly underneath the skin, so it's subcutaneous. Every time you gain weight, there it is. It's your friend. It's also in your organs, and it's around your organs, and it's in tissues with high energy needs. It's inside bones. It's everywhere. When you're in the looking through the microscope, you'll see adipose tissue everywhere. You'll see little fat cells here and there. The term for a fat cell is an adipocyte or adipocyte, however you want to pronounce that is fine with me. Your third loose connective tissue is called reticular tissue. And reticular tissue, reticular, remember, means network. And so in reticular tissue, you're going to find just reticular fibers. And in reticular tissue, you'll see just those fine collagen fibers. And what they do is they support white blood cells that we find in the spleen, bone marrow, and lymph nodes. So these are the lymphatic tissues right here. We find them in lymphatic tissues. So our next category under connective tissue proper is dense connective tissue. So here we had loosely arranged fibers in these first three categories, and here we're going to have the densely arranged tissues. In dense connective tissue, we have dense regular connective tissue. Here we have the fibers arranged in a dense regular fashion. We find dense regular connective tissue in our tendons, which connect muscle to bone, in our ligaments, which connect bone to bone, and in the aponeuroses. These are sheet-like tendons. Sheet-like tendons. And in our fascia. Fascia are like sheet-like tendons that wrap around muscles, or they're between muscles and skin. It's that stuff that you scrape off, that you peel off of things before you cook. You know, the outside of, say, ribs, etc. In dense irregular connective tissue, we have dense collagen fibers, but they're arranged irregularly. We find this in the dermis of our skin. You've probably seen this in lab, or if you haven't seen it yet, you will. And the collagen fibers are arranged in a regular fashion, or in our joint capsules. And those are capsules that surround our joints. In the elastic dense connective tissue, we find an abundance of elastic fibers. We find this in the ligamentum nuchae and the ligamentum flava. These are ligaments in our neck and in our upper neck, and we find this in our aorta. So we have a lot of rebound elasticity. Okay, then we have our cartilage. Cartilage is our next connective tissue type. In cartilage, we have three types: hyaline cartilage, elastic cartilage, and fiber cartilage. See how we have two types of elastic here? So remember to say elastic connective tissue and elastic cartilage. So in elastic cartilage, we have elastic cartilage. We find that in our ears and our epiglottis. So I try to tell students to remember ears, elastic cartilage, E for elastic, E for ears, ears, E for epiglottis. Our epiglottis covers our trachea so we don't get food down in it, food down in our windpipe. And then we have that elastic cartilage in our ears. It's got a lot, elastic cartilage has a lot of elastic fibers in it for flexibility. Back to our hyaline cartilage. Hyaline cartilage is the most abundant cartilage in the body. We find it in our nose to give it support. It's in our septal cartilage that separates the left and right halves of your nose. Articular surfaces, those would be in our joints, on the surfaces of our bones. Our costal cartilages are the cartilages that connect our ribs to our sternum. Also, when you're an embryo, you start out mostly as a cartilaginous skeleton, and then right after birth, your skeleton turns completely into bone. The epiphyseal plates are your growth plates, where you grow at the ends of your long bones, and the respiratory cartilages, where you have quite a bit of cartilage down in your lungs. Fiber cartilage is a type of cartilage that's a very strong cartilage. All your cartilages are going to be for tension and compression, but this cartilage is much stronger than your hyaline and your elastic cartilage because we find it in places where we need a lot of compression. That would be in your intervertebral disc. Those are the discs between your vertebrae. The menisci of the knees. Those are the big pads when you're between your femur and your tibia. And the pubic symphysis between your two pubic bones. The bone is the next connective tissue type, and we have two types of bone found in bone. Compact bone, that's what you're going to look at in lab. It has little osteons with the lacunae in them, and cancellous tissue, which is what we call spongy bone. And then blood. We'll look at this in a minute. So here is areolar connective tissue. And areolar connective tissue has just a wide, this is what we call the prototype connective tissue because it just shows how many different substances we can find in connective tissue. How many different types of cells, how many different types of fibers can be present, and the different types of ground substance in the back. So let's start with ground substance in the back here. This is our ground substance, the extracellular matrix, if you will. The extracellular matrix would be composed of the ground substance back here and the fibers. But the extracellular matrix, or the ground substance back here, would have the proteoglycans in it and the glycosaminoglycans. Now, the glycosaminoglycans can be hyaluronic chondroitin sulfate, keratin sulfate, or hyaluronic acid. And all of those glycosaminoglycans could trap water and make this background, if we're areolar connective tissue, more molasses-like, to give this macrophage something to swim around in. Give it some viscosity to swim around in. Excuse me. Also, the more glycosaminoglycans we have, the more viscous this would become and the more easy it would be to trap water, and you could have some inflammation occurring. All right, if need be. Now, any water that's in the background of this interstitial fluid would be coming from this blood vessel here. If we wanted more water in this area to swell up, we could get some swelling to occur if this cell here, this is a mast cell, were to release histamine. Mast cells mediate inflammation. So let's go over some cells right now. Mast cells mediate inflammation. They have granules that contain heparin. Heparin is usually a blood thinner, but in the mast cell case, it doesn't work that way. But I want you to focus on the fact that mast cells release histamine, which cause these blood vessels right here to become leaky and release more fluid into this area to cause inflammation. The lymphocytes that you see here, the lymphocytes, the neutrophils, the plasma cells, these are all part of your immune system. They're for immunity. If you get a cut, or if any bacteria were to be introduced into this area, or if anything were to come into this area that needed to be taken care of, your immune cells are already there to take care of that. This macrophage here is macro for big, phage for eater. Macrophages creep around the area, making sure they're just going to eat anything that's not supposed to be there. They're also one of your first lines of defenses. See another cell, fat cells. These fat cells or adipocytes are there to store energy. So they've got this big fat globule in there full of triglycerides. And here's our fibroblast. Your fibroblast is your cell type for all connective tissues, for all connective tissue proper. So this is for fibroblast, and what the fibroblast does is it makes all the fiber types that you see here. And so this is our last cell type, so I can go on to the fiber types. Collagen, this is the collagen right here, these big fibers here, and collagen fibers are for tensile strength. They're for strength. Our next fiber type would be the reticular fibers that you see here in blue. The reticular fibers, they're forming a mesh network in the background. So the reticular fibers are for support for all those cells. They're forming a network for those cells to reside on. And then our last fiber type is the elastic fiber. So those elastic fibers are for recoil and elasticity. So there are all of our fiber types. And then here we have a nerve going through. That's not a fiber. They call it a nerve fiber. It is a nerve fiber, but that's for sensation, for communication. So that's about it for our prototype. So this tells you everything that could be in your areolar connective tissue. This is under all epithelial tissue, all over throughout the body. So these are all the substances that can be there. I showed this to you in class. I'm not going to click on it now because the videos really don't work, I've been told in class. If you want to copy this down, this is of that worm in someone's small intestines creeping through. So if you want to look at it, it's a good video. Alright, and this is just the updated picture showing you the same exact areolar connective tissue, the prototype for the connective tissue for this class. Alright, now here we start. This is mesenchyme. So these are those embryonic cells right here. These mesenchymal cells will differentiate into the fibroblast, or they'll differentiate into chondroblast, or osteoblast, or the hematopoietic stem cells to give rise to all the different types of connective tissues. Alright, this is what areolar connective tissue looks like. This is what it looks like when you stretch it out underneath a microscope to look at it. So here we have an epithelial tissue, and I hope you recognize this connective tissue, this epithelial tissue. It has many layers, dome-like cells on the top. So what is it? That's right, It's transitional epithelium. Very good. This is transitional epithelium. So here, if this is epithelial tissue, we know it has to have at least a scanty layer of areolar connective tissue underneath it. So this is areolar connective tissue, and I want you to focus on this word right here. This is a fancy word. It's lamina propria. When we have areolar connective tissue underneath an epithelial tissue that opens up to the outside of the body, we call it a lamina propria. This is a mucous membrane. We haven't gone, if you've not watched the lecture on mucous membranes yet, you will. When areolar connective tissue is underneath an epithelium that opens up to the outside of the body, we call it a mucous membrane. So we call this areolar connective tissue a lamina propria. So it's a lamina propria when the areolar connective tissue is underneath an epithelium that opens up to the outside of the body. And since transitional epithelium is in the bladder, and the bladder opens up to the outside of the body, that's when we call the areolar connective tissue lamina propria. So that's what this word means. But here we can't tell the cells. We can't tell which is a fibroblast, which is a white blood cell, which is, a mast cell really in this picture. So we just say, oh, that's a fibroblast. But the big fibers are collagen fibers. These little ones that are like this are elastic fibers. Maybe this one right here, these might be reticular fibers. It's hard to tell them apart. I might say the biggest ones are collagen fibers for sure. But this is the tissue in the body that's responsible for edema, for swelling. It surrounds your organs. It cushions your organs. It holds fluid. It supports. It's everywhere. Now here's fat. Here's what fat looks like. We have an adipocyte. It's full of triglycerides. The nucleus is pushed out to the outside. It stores energy. There's white fat and brown fat. We have white fat. Brown fat is stored in babies. There's a picture here that is a dead link, so I'm not going to click on it. I think it's a dead link, so if I click on it, it's gone. I had a picture of a baby, and it worked earlier, and it didn't work later on, so I'm not going to do it. But it's a picture of a baby with showing you where the brown fat is stored on the baby behind the shoulder blades. But here's showing you where fat is distributed in the breast of a female. We have lots of fat in our bellies. Not all of you. Whatever. Maybe you'll get it one day. Haha. Some of us more than others. But we definitely store it under our skin subcutaneously. We store it behind our eyeballs. We store it around our kidneys and in some organs. Helps protect our organs. And here's our last loose connective tissue, which is called reticular. And here we have our reticular fibers all through here. This is what reticular fibers look like. They get thin in some areas and they get thick in other areas. And reticular fibers are just a type of collagen fibers, but we call them reticular fibers, and we find them in the lymphoid organs, lymph nodes, bone marrow, and the spleen. They just form internal, we call it a stroma, an internal structure or an internal skeleton or stroma, internal structure for soft organs. So now we're getting into our dense regular connective tissues, or dense connective tissues. Here we have dense regular connective tissue where all of the collagen fibers are going in one direction here. And here we have our nucleus, a nucleus to a fibroblast, and here's another nucleus to a fibroblast. And notice how these fibroblasts have to line up in a row because the collagen fibers are all going in a row. So that's how you can tell that this is dense regular connective tissue, because the nuclei are lining up in a row and the nuclei are slit-like. Some students confuse this with smooth muscle, but notice that we have slit-like nuclei and we don't see any nucleoli. No nucleoli in the nucleus. Now here we have dense regular connective tissue in the tendons, ligaments, and aponeuroses. Here's a ligament, bone to bone. Here's a tendon, bone. Bone up here is connecting bone to tendon, bone to muscle. This is going to be the same picture as in the next one, because we're going to the next picture, which is dense irregular. And dense irregular in the next picture, this area will be highlighted because this is the joint capsule of the shoulder. The function of dense regular connective tissue is going to be we're pulling force in one direction, and dense irregular we're going to be pulling forces in many different directions. So here's dense irregular connective tissue where the collagen fibers are going in many different directions. So if you're going in many different directions, here we are withstanding tension in many different directions. So here it's highlighting the joint capsule, but really we're going in many different directions here. The best example of dense irregular connective tissue will definitely be the dermis of the skin, where on a daily basis we have many different directions that our skin is pulled, especially if we have kids. They're all over us like little monkeys. All right, our last connective tissue is going to be dense as elastic connective tissue. Look at all the elastic fibers in elastic connective tissue. All these elastic fibers. Because when the blood is pumped out of the heart, this aorta is going to really stretch outward, and we want that when it stretches outward to recoil back to propel the blood on through the body. So we need a lot of recoil here. That's going to be the function, the recoil of the tissue to allow stretching that follows the stretching. So that's going to be the function. It's going to be in the walls of the aorta, and it's also going to be in the ligamentum nuchae and the ligamentum flava of the neck. So that's it for our connective tissue propers. On to our cartilage. When it comes to cartilage, we have these cells called chondrocytes that once were chondroblasts. When they were chondroblasts, they made the cartilage, but once they got trapped in these little caves a cave is called a lacuna, plural is lacunae, you put an E on the end. Once they got trapped in the lacunae, they differentiated into these cells called chondrocytes. So here we have a chondrocyte right here, and this is its nucleus right here. So here's a chondrocyte. So I can always tell the cartilages because I see these little pair of eyes right here looking at me. So here's a pair of eyes. I call them owl eyes. When I see owl eyes looking at me, I know I'm looking at cartilage. So here's a set of owl eyes looking at me. And here's hyaline cartilage. It's called hyaline cartilage because it looks very glassy, kind of smooth. It does have collagen fibers in the matrix, in the background. This matrix is solid because of the high amount of hyaluronic acid, which is a glycosaminoglycan. So it's trapped a lot of water in here. It's got a solid matrix. But the collagen fibers are very fine and you cannot see them, so it has a glassy appearance. We also call this gristle. Blech, blech, yuck. You get a lot of gristle in McDonald's hamburger. Ugh. But they grind it so fine that hopefully you won't. Back in the 80s, they didn't grind it so fine, so we used to get gristle all the time. That's why I don't eat many McDonald's hamburgers. Now they grind it a little better, so you don't get it so much. But anyway, every now and then you get a little gristle. That's called cartilage. It's nice. And it's this hyaline cartilage. So yummy. Okay, anyway, so here's our chondrocyte, and here's the little nucleus in it. It's the most abundant cartilage in the body, and here we see our costal cartilages, but we find it everywhere else, like the trachea, and the nose, and the larynx, and the ends of the long bones, the embryonic skeleton. It's just everywhere. Remember, the function for all the cartilages is going to be tension and compression. No blood supply in cartilage. That means avascular. And it doesn't have a nerve supply. It is not innervated. Not innervated. No blood supply, and then no nerve supply. Now here's elastic cartilage. We only find it in two places, the ear and the epiglottis, and it has great flexibility. So that's its function, flexibility. Well, in the epiglottis, it prevents you from dying every day, so that's a good thing. Now, here are our little set of owl eyes right here, or right here. If you turn to the side, you can see the owl eyes looking at you. And it's just like, see how the little elastic looking at you? All the little elastic fibers, looks like hair. To me, it looks like it's been dropped on a hairdresser's floor and all the little hair pieces stuck to it. Those are elastic fibers. Sticking everywhere, sticking all over the place to it, elastic fibers everywhere. That's what it looks like. Our last one is fibrocartilage. It's much stronger, lots of tensile strength because it has all these collagen fibers that are clearly, you can clearly see it on a microscope. So collagen fibers everywhere. Here's our little owl eyes. Here they are again looking at you. They look a little more wicked on this slide, but these are little, this is what collagen or fibrocartilage looks like. We find these in places where we really need a lot of tensile strength with compressibility, and that would be in areas of the intervertebral disc. So here we see intervertebral disc. Here's our vertebrae, hence the name intervertebral disc. So intervertebral disc here. And then we have it in our pubic symphysis. This is the area where we, between the pubic bones, our pubic bones come together at this area. That means symphysis. And the disc of the knee joint are called the menisci. So that's where we have our fibrocartilage. On to our last, no, it's our third type of connective tissue, which is bone. Now, bone provides support and protection, and also we store calcium there, and it's a site for hematopoiesis, which is blood formation. So there's a lot going on in bone. Here's where our bone cells are. Our bone cells are called osteocytes. These little black things are the osteocytes themselves, and they live in caves called lacunae, just like in cartilage. But in the bone is very well vascularized. Great blood supply in bone, great nerve supply. If you break a bone, you feel it. If you break a bone, it bleeds. So there's a great blood supply, great nerve supply. Unlike cartilage, no nerve supply, no blood supply. Great nerve supply, great blood supply. You break a bone, it heals well. You break a bone, it bleeds well. So that's about it for bone. Okay, here we go to blood. Now, blood transports respiratory gas, nutrients, waste, other substances. Also, because of these things, platelets, it protects you by allowing you not to bleed out. Protects you for immunity because of white blood cells here. Here are red blood cells. The plasma in the background is a liquid substance. It's a liquid, unlike the other ground substances. We have liquid ground substance here, and the fibers are soluble. Fibers are soluble. There are no fibers in blood. There's no collagen fibers. There are no reticular fibers, and there are no elastic fibers. We have a fiber that's soluble. It only comes out of solution when blood clots. It's called fibrinogen. So I did not point that out in class, and I apologize for that. But it's a soluble fiber. Now we find blood inside of our blood vessels. Here's where we find blood, inside of our blood vessels. And that's it for our last connective tissue. If you've got any questions on connective tissue, you definitely need to ask, because connective tissue is a massive, massive category. Read connective tissue over again, twice, 3 times, 4 times. Good luck.